In fact, here at IIT Rookie, you can irrigate it with tertiary wastewater. You might think I'm kidding. I'm not. All right. Because if you really do want to use a green roof here, then my hunch is that you would need to irrigate it in the off season. That is when it's not heavily raining. You don't need to put tons of water on it, but you'd want to have some of just so that those vegetation can handle the extreme drought periods that they are subjected to. And here's a green roof in North Carolina. Thank you and thank you. I appreciate that very much. Are there any jelly bees out there? Any jelly bees? Is that possible? It is? Okay. I love jelly bees. Is that what you call them? Jelly bees? Yeah, I love them. But I can't eat like lots of them because I'll get like super fat. I'm already mini fat. I don't want to get super fat. And I walk. I don't know what's happening. You get a little bit older. All right. That's one of my boys. And there we are at the NC State campus. This is actually the engineering quad at NC State. I don't know if you guys are familiar. NC State's a pretty good engineering school. My alma mater is a pretty good engineering school. Civil, chemical. Any y'all chemical engineers? We're very good chemical engineering school. Civil engineering is really good too. And if you're biological, we're very good biological engineering school. Okay. Now there's two different types of green roofs. And they're German. The name derives from German, okay? And so in English, it's like, it doesn't. Intensive and extensive. All right, intensive and extensive. Intensive green roofs are green roofs that are intended to have people on them. You get up there, you congregate. If you see a water feature on your roof, that's an intensive green roof. Okay, think of it this way. The design for them needs to be pretty intensive. Here's one in North Carolina. That's a spa. All right. Then there's extensive green roofs. Extensive green roofs. Thank you. These are better? Let's try this. Excuse me one second. What's made? Are they made of peanuts? I'm about to find out. They're pretty good. Peda. Yes. Peda. These are pretty good. You guys like these? I don't even know what that's about. But I am going to tell you this. I know that all these attempts I have at using Hindi words are really bad. But I appreciate your graciousness in allowing me to continue to mess up your language. All right. But I do try. It's still morning. So prabat. Is that right? You're basically saying it's close. In extensive. So extensive green roofs, you could say, can be used extensively. What makes them different from intensive green roofs is they're not intended for people to go up on them frequently. Yes, you go up, you can maintain them, but the idea is you keep people off. They are, some people will call them garden blankets or roof blankets, all right? Or, yeah, roof blankets or roof lawn. That's kind of what that is. It's not intended for you to go up there. Here's an example of an extensive roof. They're low-lying. Most of the green roofs that we see used across the globe are extensive. Do you know why? There is a real reason for it. Why do you think extensive green roofs are used more than intensive green roofs? You ready? I'm going to bring this close so everyone can hear it really well. Money, money, money. All right. And then there's something called a blue roof. I wish I could hit that. I can't hit those notes anymore. I was going for money, money, money. I can't do it. But you know what I'm going for, right? So this is a green roof. This is a blue roof. It doesn't look blue. I get it. It does not look blue. You want to call it a gray roof or something, but the idea behind it is that you pond water on the roof. We talked about this on Tuesday, okay? But this is how it's done. Part of the reason to have the gravel up on that might have been, this might even be cobble size, but we'll go gravel, cobble, is that that warms up a little bit and actually promotes evaporation. It promotes evaporation, okay? This is a blue roof, green roof mix. Essentially, the way blue roofs work right now is you'll have these trays. These trays will be filled with an aggregate so they don't blow away. They lift those trays up, drop them onto the roof. That's how it works. Now, part of the advantage of that is you're not putting the aggregate directly on liners because the aggregate could puncture liners. And so instead, you're putting a plastic bin, all right, that's filled with aggregate on the liners. And that is basically makes it a little less apt that the liners get punctured, all right? Plus, you can put that on a slope, right? You put it on a slope, then each of those trays can be on a little slope, but you can still pond water, all right? If you don't have those trays and you're on a slope or on a pitch, your water storage ability really goes down. All right, so that's a blue roof. I'm not going to talk much more about blue roofs other than they're probably underutilized. They're probably underutilized. People are more into the green roof in Great Park because they look better. All right. Plus, there's an industry that promotes green roofs, and the same industry sort of promotes blue roofs, but not as much because green roofs. You know why? Guess which product brings more money into the industry? Take a guess. Green roofs. That's why we have green roofs. Y'all know the Dr. Seuss book, The Lorax. Every environmental person needs to read The Lorax. It will take you about 10 minutes. It's a children's book. It was a very influential children's book in the United States because it's basically the Lorax is a character who speaks for the trees, right? So a lot of the stormwater, there isn't anyone speaking for the stormwater practice unless someone sells it, all right, makes it and sells it. Green roofs get promoted because people make money by selling those products, all right? Now, how a green roof works is you've got your deck itself, all right, your waterproofing layer, and then it depends on the manufacturer, but the basics are there will be a media, there may be a water storage, a plastic sheet or whatever that's good for water storage. There's the media, and then there's plants, all right? Now, sometimes they'll try to sell you even more stuff, but remember, someone's selling you more stuff. You get that? Someone is selling you more stuff. So whether or not you need all of it, you need some of it. More is okay, but they are selling. Here's an example of one where you have a water storage thing, you have a root membrane, you got your media, and you got your plants right after it was built. All right. Now, the media itself is the key, besides the plants, to a green roof. Do you think folks take standard soil that you have, outside in Rookie and throw it up onto the roof? Nope. Do you even think people would take, let's say you had a sand mine. Sand is pretty high permeability. You think people take sand, mine the sand, and throw it up on the roof? Nope. Why? Well, one of the big drawbacks, there's a couple of reasons, but one of the big drawbacks is that native soils are heavier. Okay, they're heavier. And you're putting it up onto the roof, which means your roof is going to be heavier. All right. And the heavier the load on your roof, the less apt you are able to use it. Okay. And so green roofs tend to employ a media that is special. In North Carolina and in North America, most of what is used is something called expanded slate. you're looking at a particle, and that'd be about that big, okay? Looking at a particle of expanded slate. What do you see in this particle? What piece? It's really a small piece of gravel. What do you see in this small piece of expanded slate gravel? What jumps out at you? Kind of looks the surface of the moon, right? Not that we've ever seen the surface of the moon, but what I envision it to be. What's that? Yeah, voids, like little pockets, all right? So you might be wondering, where do those pockets come from? That's what I would be wondering. Well, it's the process associated with making expanded slate, and that process involves a lot of heat, okay? They'll literally take it, and they'll take that slate and they cook it for like 30 minutes at, I think, temperatures exceeding 2,000 degrees Celsius. It's hot, man. And what it does is it burns out all these impurities, makes the particle more porous, and you know what it also does? It makes it lighter. It makes it lighter. So in North America, we tend to use expanded slate. In Europe, they tend to use expanded clay. Okay? Really, it's expanded brick. So they'll have bricks, and then they'll break basically the bricks as they've gotten older, they will break them up and they will heat them. And as a result, you'll get a lighter weight particle. All right. But all of them have been heated at some point, and they all have these extra pockets so that they can hold water and nutrients that might be in the water. And those nutrients are really important because you're trying to get plants to grow in them. All right. So now let's talk a little bit about what green roofs do for you. Now, some of these things are real and some of these things are perceived. What do I mean by that? What's the difference between a real benefit and a perceived benefit? I think what you said, I think, is right on. All right. Real is that it's like legit, we know. Perceived is something that people think it does, but we don't know for sure. Remember, I told you there is an industry that promotes the use of green roofs. Okay. So is it in their interest, especially in the short run, to try to promote as many potential benefits as possible? Sure, it is, because they're trying to get you to buy it, right? So let's go through and talk about the real and perceived benefits of green roofs. These two, first and third, are the ones that are most associated with stormwater control, but there's others. Okay, so here is where the United States keeps some of its money. Okay, there are multiple banks across the United States, federal, basically reserves across the United States. This is a green roof on top of that national bank. Okay. I went to go meet the guy that ran the bank, and I wanted to ask him, why do you have a green roof? And I asked him that. And I said, is it because you're in Charlotte and they care about stormwater runoff? And he's like, no. I said, is it because you were concerned about heat island? All right. And you wanted the federal government doing its part to reduce the heat island effect? And he goes, no. I don't know. I said, well, why did you use it? Because I kind of run out. And I said, well, you made to use it. I said, the federal government make you use it. He's like, no. I said, well, why did you put a green roof on your roof? And he goes, because this is the bank where all the money is stored. We're not moving, right? We're not moving. And I don't like having to repair my roof. And if I put a standard roof in here, I'd have to get in there in a 15 to 20 years and redo it. He said, if I put this green roof up here, I don't think I'm gonna have to redo that roof, or whoever succeeds me will have to redo this roof probably for 50 or 60 years. I'm like, so why? And this is a guy who knows about finances, right? He runs the bank. So why would a green roof enable or have a much longer roof life than a standard roof? Which gets us to the next question. What causes roofs to fail? Water's one of them. But what did you say? Okay. What else you guys got? Temperature, ultraviolet light. Okay. Roof membranes actually fail most frequently to UV light exposure and temperatures, especially when it's really hot and then cool, really hot and cool, because there's the slightest of expansion and contraction. And by really hot, I mean 60, 70 degrees C, dropping down to 25 at night. Okay, if you just boom, 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 do that enough, eventually the membrane will fail. Well, what does a green roof do? A green roof, you saw a picture of it, the membrane's here, right? You put a media on top of it with vegetation on that media. Where's the UV light going to go? It's going to go up here. Is the UV light hitting the membrane? Sure isn't. And what do you think 15 or even 10 centimeters of green roof media will do to the temperature at the membrane? Where's the heat being absorbed in this roof? At the vegetative layer, right? So it's a bit of an insulation so that at the membrane, it's just not as hot, all right? So those two things explain why the guy who runs the bank, the federal bank in Charlotte, North Carolina, is like, let's put a green roof on this because I don't want to have to change my roof again. So there it is. That is a real benefit. And it's a pretty cool story, if you ask me. And I wouldn't have appreciated it until I interviewed that guy. That's a realized benefit. And here is the proof in the pudding, a study done, my God, 20 years ago. It's crazy. Where you can see a roof that didn't have any media on it. It was up to 75 degrees C. That membrane, if you had 7.5 centimeters, had cut that temperature in half, right? At the hottest point in the day. That is pretty good. If you added an extra centimeter, then you reduced it by a further 10 degrees. Arguments again for having a little bit more media, and all that makes sense. That's real stuff. Now, another benefit that people will say is, oh, well, you can reduce your heating and cooling costs. That's more of a perceived benefit. Is it true? Yep, on the margins. But I mean, literally 1.8%. You're not saving enough money on your roof to make that worth it. All right, there's got to be other things you're going to do instead. This is an add-on benefit. It's not a reason to really do it. How about the idea of having the roof be an amenity? All right. Is that a perceived or realized benefit? Well, what's your guess? Do you think this helps sell green roofs? That, hey, you can have a roof that is green and you can look out on it. Do you think that makes a difference? I think I see some yeses. All right. I got another story for you. So I have a pretty good buddy. or had a good, I mean, he's still a nice guy, but I don't work with him anymore, who did this project in Baltimore, Maryland. And what he did was they took an old warehouse building that was U-shaped, okay, like that. And this company called Montgomery Ward stored a bunch of, kind of like what Amazon does. I don't, Amazon's here, of course, right? Kind of what Amazon does, where they store all these goods in a warehouse, then you order them and they ship them out, okay? Amazon uses trucks. Well, back in the day, this is literally 80 years ago, they used trains, okay? So this big building with a train that they would load, and then that train would take whatever furniture, stoves, pots and pans, and they would send that down to North Carolina. They get on the train, and the train would carry that down to North Carolina to a store in North Carolina. All right. Well, eventually Montgomery Ward goes out of business. This building behind me lies vacant. Somebody buys it and says, I'm going to turn this into offices. All right. So you can imagine having an office building and it has a train shed in the middle of it. So someone convinced the owner to turn that into a green roof. You can see the green roof right here. Do you think the owner was happy he did that or not happy? How many are like, he was happy? How many are like, he was not happy? Thought it was a waste of money. Okay. Well, this is what the owner said. I can tell you this for a fact. He said, when we price out how much money we make from leasing offices, we don't expect offices to be leased out immediately. In fact, once you open up a building, you expect the offices that face outside, all right, those that have nice views of the city, to be rented within a year. And you expect offices on the inside to be rented, all of them, within 3 years. That apparently was the industry standard at the time. 1 year outside, 3 years inside. He said, I had no idea that people would love looking at a green roof so much. Instead of taking 3 years for me to lease out all my offices on the inside, it took me 9 months. He said that by the time that building was 1 year old, he had made money off his green roof. Isn't that cool? Because people were willing to pay more for what is otherwise a ho-hum view. But because you're looking onto a green roof, it's not as ugly as it could have been. In fact, I'd actually argue it's actually pretty nice looking. Most importantly, the companies who decided to lease offices, they thought it was pretty nice looking too. And so he was thrilled that he had actually turned that train roof into a green roof because he made money. If y'all ever want to have people do the right thing environmentally, I'm serious about this one. Take this one home. This is 53 years of experience in life talking to you. Convince them, and it has to be true, all right? Convince them that they're going to make money by doing the right thing. Guess what? People will do the right thing. But you do have to, they have to make money. Most people are not going to be that charitable. There's some fraction of people that are, but most people are not going to be that charitable. But they will do the right thing. They will break from their mold. And we learn about inertia in physics, right? Inertia is not just a body at rest will tend to remain at rest, and a body in motion will tend to remain in motion. It's also about people. People are probably the most inert objects on earth, right? If they're doing something that they think works, they're going to keep doing it. All right? And so it's often very hard to convince them to try something new because in their mind, what they're doing already works. Like, why do you want me to do this and take a risk? All right? Just FYI. Y'all, some of you already know this, and some of you, all of you probably know it, and I'm just reinforcing it. But it's hard to break people's inertia, but once you do, and if what you sell them works, they are, and the thing that breaks that inertia is convincing them they'll make more money. Convincing them they'll make more money. All right, I think I talked about this one already, so I'll skip through that, but it's kind of cool. Now, we have monitored these green roofs. Darn it. So that's 7.5 centimeters. That's 10 centimeters. And that's 10 centimeters. All right, so that's how deep these green roofs are. And what I want you to focus on is the amount of water that each of those green roofs was able to retain. So over 50%, in one case, 70%. In our best, the practice, the site where we had the best monitoring data, we had 63% of that water get retained. All right. So essentially what's happening is the water is getting stored in the media and then evapotranspires in between events. All right. And I apologize for not converting this to SI, but you get the point. All right. Here's another case where you see the rainfall hydrographs, and then you can see the hydrographs. And what you see here is that really intense rains. In this case, the green roof was just filling up with water, okay? By the time it was done, there was a fair amount of water in there, and you started getting runoff when you had really intense rains. But for the most part, these storms are being captured, which I think is pretty cool. All right. From a curve number perspective, here's curve numbers we've calculated. I'm just going to skip through that, but I do want to talk about this. We also looked at how well blue roofs worked vis-a-vis green roofs for runoff mitigation. And here's an example blue roof and a blue roof tray and a green roof tray. All right. We also had control roof trays that had neither green nor blue material in it. It was just a roof. And that served as our control. I showed this slide on Tuesday, but it's going to mean more now. This is the amount of water that ran off the control roof right up here. All right. And here's the blue roof and here's the green roof. And this is the amount of water that ran off those two roofs. So effectively, the blue roof and the green roof worked the same. And it was about 1/2 the amount of runoff, a little bit less than 1/2 the amount of runoff that the control roof had. All right. I actually have a lot of studies I could share with you about how well green roofs and especially green roofs, but also a couple of blue roofs work. I just want to hopefully illustrate that they do work. They do a good job of reducing runoff volumes as well as mitigating peak flows. They do. They mitigate peak flows. Okay. So if someone says you've got green roof runoff reduction, then that's a real benefit. Now, let's talk about green roof water quality. So I had this really cool project. I don't have a good slide of it, but I can draw it for you. I had a building, and I'm looking down, bird's eye view of this building. All right, here it is. This is the bird's eye view, and I had a barrier right here. All right. And in the middle of these two, I had an underdrain. One of these two, I'm just going to pick one. All right. One of these two, I turned into a green roof. And one of these two, I just left as a standard roof. Okay. So we monitored this and we would collect samples. The under drains were internal. The drain was here. It was internal. It would come down here, then go down the wall, and then the under drain would discharge literally right here. Okay. And so then I set up a sampler unit that would capture the water from this discharge point and that discharge point. So I got water. Whoa, that was loud. I got water that came off the green roof, and I got water that came off the control roof. You're looking at the two jars. One of those jars is filled with green roof. We'll call it runoff or outflow. One of those jars is filled with control roof outflow. which one is which. All right. So we're just going to vote on green roof. As we look at the green roof, all of you who think that the jar on the left is green roof drainage, raise your left hand. Okay. All right. Put that hand down. All of you, as you look at this chart, this picture, and you see the jar on the right, and you think that's green roof drainage, raise your right hand. So it's dividing you into optimists and pessimists. The optimist in you is like, I want that green roof water to be clear. The pessimist is, Dr. Hunt's kind of talking weird about this. I'm a little worried. The green roof is that one. Those of you raise your right hands. So should we be shocked? Should we be shocked? Well, what's on top of a roof? Media with some compost in it to help get plants to grow. What don't you have in a control roof? Media with compost in it to help get plants to grow. Green roofs from a nutrient standpoint, ready for this, are not good. Boom, boom, boom. Say it again. Oh, that had gotten in there? It's possible. We can take a quick look. Oh, it looks like grass. That's yeah. That's actually what's growing along the base, and that's what you see there. Yeah, that's it. So here's another blue roof, green roof study. See if I have it highlighted. I'll just look at this. This is phosphorus. This green line is the phosphorus that's being discharged from the green roof. This gray line is the phosphorus being discharged from the control roof. And this blue line is the cumulative phosphorus leaving the blue roof. The gray and the blue are actually not discernibly different. They look higher. Blue's higher, but they're about the same. Yeah. Another example. If you want, I can keep going. That the greens is what's leaving the green roof. Okay. So the problem is, and I was talking to someone before about the tug of war, the balancing act of different storms. Oh, it was albedo related. So, you can use permeable pavement to help treat runoff, but if you use the blocks, they're better at reducing runoff than if you use a grass system. But the grass system has lower albedo. Okay, so it's a balancing act. Which one you want to go with? All right. Well, with green roofs, the balancing act is, am I okay for my plants not to look as good or to flourish or to have to replant as I balance out keeping my nitrogen and phosphorus concentrations lower? That's what the tug of war is. Do you want your roof to look good, but then very likely discharge a lot of nutrients? Or do you want your roof to struggle how it looks, but do a better job of nitrogen? They don't do a great job of nitrogen treatment. They won't. They're not designed to. They don't have anaerobic zones, like intentionally. They're not designed for nutrient removal, okay? But you can have it so they don't add as much nutrient, all right? So this is a classic case of what should you do? And the answer is, I guess it just depends. In North Carolina, we worry about nitrogen and phosphorus, so they've made the decision to let the green roofs kind of look, In other places, they want those green roofs to be flourishing and look really good. And they're like, well, I guess we're just going to have to discharge extra nitrogen and phosphorus. Okay? So it's literally up to you. Now, one of the ways that in North Carolina we limit the amount of nutrients in the runoff. We don't eliminate it, and there's still more than we would have had if we didn't have a green roof, okay? Is that we reduce the fraction of compost. Like if you have a compost here of what's that, 30%, 20%, that's too high. That's too high in terms of nutrients that are going to be discharged. So we try to limit the fraction of compost, organic matter that we put on that roof. Whoa, we're good. We're good. We limit the amount of compost that goes on the roof to try to keep the nitrogen concentrations and the phosphorus concentrations low. So in this case, you can blame the problems on the media. Now, when you're trying to specify how much media, what fraction of organic matter you can have in it, we wanted to go with 5%, all right? But there were people in the green roof industry that swore that we really needed it to be 10%, and they won the argument, okay? But just understand, the main point here is keep that organic fraction, the amount of organic matter in your media as low as possible if you're worried about nutrient discharge. If you don't care about nutrient discharge, then you don't need to worry about it, okay? But the next thing I want to talk about, and this is an important thing, is soil moisture, okay? We've got 3 cases here. This is a soil particle, all right? You guys probably got that. This is water, and the white is air, okay? There are 3 conditions being represented up here, all right? The condition where there's no air and all you got is particles and water, what's that called? Saturation. It's fully saturated. What's the condition called when through gravity drainage, all the free space water drains away and you're left with, which is basically the condition to the right. Yeah, the condition to the right. What's that condition called? Do you guys, someone say field capacity? It's field capacity. Okay. And the third condition, the one at the bottom, the plants have sucked, the plant roots have sucked all the water, mined all the water they could from around the soil particles. And all the water that's left there is that which the soil particles literally refuse to give you. What's that condition called? Very good, the wilting point. You guys did better than your average American student, let me tell you. They know about saturation, but they don't do as well on field capacity and on wilting point, all right? Boom, 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 boom. Now, if you're a plant growing on a green roof and you want access to water, all right, through that you're basically gonna take the water up and evapotranspire it, okay? Then the water you have access to actually has nothing to do with saturation. Because that water is going to drain, it's going to gravity drain out. The water that the plants can withdraw from the media is the fraction of water between field capacity and the wilting point. Everyone on board with that? All right. And so if you're trying to get an idea of how much water a green roof can retain, you have to know how much water is in the media at field capacity and subtract from it how much water is in at the wilting point. Okay? In other words, I know this sounds weird. Saturation doesn't matter. So flush that from that calculation. Okay, so plant available water is the amount of water that you've got, the difference of water between field capacity and the wilting point. So the real question is that for the media that are being used in a green roof, how much plant available water is there? Basically, how much of this water is there per centimeter or per inch of media, all right? Now, my colleague who specializes in this says that anywhere between 20 and 65% is correct. I struggle to believe that per centimeter of media that you can hold 2/3 of a centimeter of water. I struggle to believe it. But you know what I don't struggle to believe? Is that you can hold per centimeter of media that you can hold a quarter of a centimeter or a fifth of a centimeter or a sixth of a centimeter. That I do believe. All right. And so I went ahead and for North Carolina, I said, you know what? Let's go ahead and just give the media the plant available water. Let's give it 25% per centimeter. All right. 25% per centimeter. So why is that plant of available water fraction so important? Because it relates to how much media you need to capture a certain size storm event. So what would the design storm event be in a place like Rookie? What's the water quality? What's the design storm or the water quality depth in Rookie? 35 millimeters. You're like, you keep asking me this question. You know why I keep asking you the question? You keep answering it. It's because it's a super important question, right? Once you've identified that storm size, it pertains to almost every, not swales, but most every other SCM. You need to know that what that 35 millimeter depth is, all right? So if you're trying to figure out how deep your green roof is, you got your design storm depth, that's DSD. Design storm depth is 35 millimeters. Your plant available water, 0.2, 0.25, somewhere in there. You divide 35 millimeters by 0.25, and voila, you are going to get, I have this, you're going to get your depth. So let's see if I have I'm going to have you guys do a real quick calculation. All right. So go ahead and do this for me. I think I have this to be done a little bit later, but I'm going to let it go. All right. We're going to do this right now. Let's say you are trying, oh, I've got an idea. Let's say you have been contacted by the White Rabbit, a restaurant here in town. Been contacted by the White Rabbit to put a green roof up on that building because they've heard that they're cool. All right. They're like, okay, I'm going to do it. So you tell me if the White Rabbit wants a green roof, you have to tell me how many. I'm going to have you do this right now, okay? How many centimeters of media do you need? All right. How many centimeters of media do you need? If y'all would tell me that, let's see what we get. Okay. How many centimeters of media do you need if you are in a green roof, GR, in Rookie, that is designed to capture the water quality volume? And I have a feeling if anyone, is it dead again? When y'all get it, let me know. I think you're telling me the answer. Thank you so much. I'm just going to take one of those right now. Thank you. What answer did you get? 14 centimeters. That seems exactly right. Because in North Carolina, we have a 1.5 inch rain requires 6 inches, which is 15 centimeters. A 1.5 is a little bit more than 35 millimeters. So 14 centimeters. There you go. And then it's up to the white rabbit to decide if that's good or bad. All right, that's them. So our minimum design is 10 centimeters, unless you irrigate it, and then we go with 3 inches or 7.5 centimeters. All right. You may have to consider thinking about some irrigation on a green roof here if you want the plants to take. We did that one already. I skipped through it. I was excited. How about a maximum pitch? You can actually have your roof on quite a bit of a pitch, all right? But if you do that, you have to have a containerized system like you see right here. Flat roofs, you don't have to worry about anything like that. Here's an example in Germany where they didn't have a containerized system, and you can literally see how the media is sliding off the roof. Let me show you another case. This one I think is in Estonia. This was given to me by my buddy. And this is the green roof media that slid off this roof. They had placed it all on and it literally slid off. They should have used a containerized system. Okay. Couple other things. You should protect your drainage elements, meaning as the water flows through that media, it comes to drains. You want to make sure that those drains are right, because if you don't make sure that the drains are freed from clogging and they clog, what will happen to your roof? It will saturate. And what does that mean from a weight standpoint? It's heavy. All right. So that is stuff you want to be mindful of. So you want to make sure it doesn't clog. You also make sure that when you put your green roof up, you want to make sure that you do it at the very end. Because if you don't do it at the very end, it will get trampled. And extensive green roofs are very sensitive roofs. You guys have any friends that offend easily? Like you kid around, you tell them a joke, and all of a sudden, oh, you hurt my feelings, right? That's what green roofs are like. Their feelings get hurt very easily. All right. So you don't want to pull them. Now, what's that? Okay. How do you build them? There's different ways. You can bring the roof media up. That's being done. This is by Shingle Lift. Now, the Germans, who do a ton world of green roofs, here's media being blown up. The Germans have really good mechanisms and techniques to get media up onto the roof. It's literally like it's it's the opposite of a hose. It's that. What's the word for that? There's a blower and it blows the media up. It's really cool. They have really good stuff. Now let's talk a little bit about the plants. The plants are called, most of the plants that are used are called sedum. We'll talk about where sedum come from. The idea is that your green roof will look green within a couple of years. This is pretty good. This is not so good. This one's in North Carolina where they don't let you use high compost media. All right. That's why you don't see great green roof growth. All right. Now, the plants that are used for the most part come from places like here. All right. Now, that place is pretty darn far from the United States of America. But you know where it's not pretty darn far from? India. It's up and over the Himalayas, maybe a little bit to the left. This is one of those stands. I don't know if it's Turkmenistan, Kazakhstan. Did I do Turkmenistan already? There's another one. There's a bunch of stands up there, right? Uzbekistan. Most of the green roof plants that are actually propagated and grown in Europe come from just over the Himalayas. Now, I want you to tell me why. Why do the Europeans, or why do the Americans, for that matter, unless you're in Norway and grow grass, why do they come over here to get the plants? All right. What is on the other side of the Himalayas? Is it like a rainforest? You're right. It's not a rainforest. It's actually pretty dry. All right. In fact, we'll call it a warm then cool desert, right? I know in China it's called the Gobi Desert, but it's a semi-arid, arid to semi-arid. Okay. What's it like on the roof? Is this on? Yeah. What's it like on the roof most of the time? What's that? Well, it depends. You're right. If it's raining, it's pretty darn wet. If it's not raining and the sun's out, like what's it like today? Pretty hot and dry. All right. Except at night, it can get cool. So it's not quite as hot and dry. It's still dry. So the majority of the time in North America and for most of Europe, and here too for that matter, the majority of the time, your roof is hot and dry. Just like, except in the winter when it gets cooler, it's still pretty dry. Just like what you see on the screen there. The difference is that it does get wet sometimes, which is not like there. But the plants that survive actually at their base, they are happiest in northern, it's not like super far north. It's not like we're talking Siberia, okay? But in the climates just northwest of you, that's where those plants are from that handle green roof conditions the best. All right. So in North America, almost all the plants that we use come from, I don't know how far this is away, a few thousand kilometers away from where we are right now. Is that kind of interesting to you? It's kind of cool, right? You don't have to go as far as we do. If you're going to use other plants, you got to irrigate. We talked about that. I want to talk a little bit about how green roofs change over time. Here's a green roof. All right. See all the how it looks. I forget what time of year this was, but same green roof. Same green roof. Same green roof. Same green roof. What did you observe? It looks a lot different, right? This is over the course of a year. It looks a lot different because the plants bloom at different times. People need to understand that when they're getting a green roof, they are getting a living system. All right. And that is actually a really cool thing. But some people get a little like, what's it going to look like? And the answer is, well, it depends. Whoa, people freak out when the answer is, it depends. Last thing I want to mention is maintenance of them. If you design green roofs, like there's a green roof up here, you got to climb up these ladders to get to it. I mean, okay, but that's not exactly easy for maintenance, right? You're not making maintenance, the design is not conducive to maintenance, all right? And then something else to be mindful of is that roofs that are irrigated, or any of them, but this one, which happens to be irrigated, can be a tripping hazard. That's not great when you're on a roof, right? It makes it even worse. This particular roof had lightning protection on it. So can you imagine tripping and impaling yourself on your roof? Try not to imagine it too much because it kind of freaks me out. All right. The point being is that green roofs are a lot different from every other stormwater control measure we've talked about. You are up on a roof. They are actually more dangerous to maintain. This is a guideline that people, if they do the maintenance at NC State, have to hook themselves onto so they don't fall over to their death. Okay. Now, the last thing I want to mention is, what do you think the principal reason that people do not use? A lot of people do use green roofs, but one of the reasons that people will not use a green roof is, you know what? I should have put the rupee, the INR, the rupee symbol up here. They're expensive, right? They're expensive. Now, can you get that back through investment? Sure. Remember the guy, the Montgomery Ward building, Baltimore, Maryland? He invested a lot of money. He got convinced to do that, but he made his money back, all right, in 3 months. They're expensive for a couple of reasons. One is they are heavier, and therefore your roof has to be made to be stronger, okay? And this is, for those of you that are in building design, this is a dead load, all right? So you have to design an extra 35 PSF or 0.73 pascals for your standard extensive roof, and intensive applications can be well over 2 pascals in terms of the weight. So that's a lot of additional weight, or a fair amount of additional weight that you have to design for. Plus, you got to buy the media. You got to get the media up on the roof. It's not cheap. In fact, all told, we'll spend typically between $100 and $250 per meter square of green roof. If we had the exact same, or if we had, and you can't replace a bioretention cell with a green roof, all right? Because green roofs go on roofs. But we're going to talk about this after the next break. Bioretention per surface area treated in 1/10 the price. So most people, when they're looking to spend money, they're like, but if it's in an ultra urban area where what you got are buildings, you got to do something. Well, then the green roof is going to kind of make some sense. All right. So hopefully over the course of this discussion that we've had this week, we'll start slotting in practices and the developed condition where practices make sense. Where you're going to use ponds and wetlands, probably where you have open spaces, right? Where you can use green roofs, where the only place you can use your treatment is going to volumes, while not being great for pollutants. It does reduce runoff volumes, and it has other benefits too, all right? But they're going to tend to be in ultra urban areas, which may make sense for huge chunks of India, all right, where you have a lot of urban areas. We have seen big cities in the West use them. This is just a picture from Chicago. There are, last time I checked, I think there's over 400 green roofs in Singapore. Green roofs are being used. They are what I call a big city stormwater control measure. If you're doing work in Mumbai, well, it might make sense. You're doing work in Delhi, probably going to make sense. Bangalore, in the heart of Bangalore, going to make some sense. This is the largest extent of my research team. So do we have, oh, God bless you. Thank you. Do we have any questions about blue roofs or green roofs before we take another little break? Yeah.